Okay, good afternoon. So I think this would be the last lesson that I will talk about divisibility. I think everything we need you already know, but of course the problems are not standard problems. Each problem probably needs a little bit of different way of thinking sometimes. So the only thing that you can do to improve your skills in discrete mathematics is just to solve as many problems as you can. Okay, I want to give you some time, actually reasonable amounts of time to start solving them, okay? And even if you can solve 1 or 2 or 3 of them, it means that your understanding is actually perfect. It means that if you give me another question that I haven't experienced before, I myself will have trouble to solve them, because this is the nature of discrete mathematics. Stating questions are very simple usually, but solving them is really hard sometimes. Okay, but I want you to do your best. Yes, I don't think so. I want you to learn at least, even if you cannot solve these problems. At the end, I want you to learn about how to think about different types of problems. There is no guarantee if you can solve this problem, you can also solve that problem. That's the nature of discrete mathematics. Okay, so I will pause recording the video and give you a reasonable amount of time. Let us see how it goes. We can solve them one by one and discuss, or I can give you more time to think about all of this. So let us start with the first one. Think about this one, and if you are done, you can raise your hand and then solve this one. We can continue. Okay, that would be a probably better idea. And I hope that I have written everything right. So at least the first one tells you that if you have a and b integers so that this is satisfied, show that automatically this one is also satisfied. Okay? So how is it going? Would you solve the first one? Do you have any idea how we can start solving that? I told you that these problems are not standard at all. So each problem, if you can solve the first one, there is no guarantee you can solve the second one. If you can solve the second one, there is no guarantee you can solve the third one. But we want to train together to learn how to think about these problems. I don't know, but you should be able to write something for me for the first example. I want to hear from you so that we can start correcting you if possible. Yes, Robert?
I'm not done with it, but you can add 4a on both sides and then subtract 6b and...
No, you cannot do that. Be careful. You are not allowed to add. Do you remember I talked about this before? These are the things that I want you to know. I told you that in equality, that is the bad thing working with this sign. It's not very friendly. Yes? In equality, if you have this one, you can add something to this and the same thing to the right. They will remain the same. They will follow the same relation. But there is no guarantee for...
Sorry, I forgot to say you make it into the equation first.
Okay, that's good. So you be careful. If A divides B, there is no guarantee that A plus C also divides B plus C, yes? Be careful about these things. So don't take these things for granted. Because we could do it for equality relation, we can also do it with divisibility relation. And I want you to feel that, because that would be the topic of the next lesson. I want you to feel that working with this strange relation is not comfortable at all. Okay? This motivates us to go to a relation which is very similar to equality, and that is called congruency, yes? Or modular arithmetic. We will call this was the reason working with this was not that friendly, but we want to go one step forward to reformulate this in a way that we can enjoy the properties of equality. That was the motivation behind, one of the motivations behind modular arithmetic. So what Ruben is saying is that probably you will start from this and write a definition and do, yes. In that case, so you say me that 7 is guaranteed to divide this, so 3a plus 4b plus 2. You shouldn't have problems So writing this would then imply there exists a q in the set of integers such that 3a plus 4b plus 2 is equal to 17 times q. Okay. Then, yes, I'm hearing from you now. Yes.
Then you add 4a on both sides.
So what was your motivation? Because you have an eye on what you want to gain, and on what you want to gain you have 7a. Yes, and somehow you want to make 7a appear in your expression. Yes. So that's a good motivation. I don't know if it is going to work or not, but this is a strategy for a problem. Just randomly adding things and writing things doesn't definitely work unless you are very, very lucky. And if you are that lucky, it's better to buy a lottery instead of doing mathematics. Yes? So here you are saying that I add 4a. But if I add 4a here, can I add 4a there? Yes, because now this is the familiar equality relation. Yes? So I add 4a to the other side. So this becomes 7. Let us do it in our head. We add 4a to both sides, according to Ruben. So what I get is 7a plus 4b plus 2, and then it becomes 17q plus 4a. So far, so good, okay? Nothing is wrong, but do you think it will work? At least I have my 7a that I need. Yes? Could you continue or no?
Yeah, you can do the same for the other things on the left-hand side. So
yes, what?
Subtract 6b and subtract.
Yes, so what you are saying now, your motivation is this minus 2b. So I can say that this is one thing. Another thing, from that I subtract minus 6b. Then I will have 3a. Let us do it in our head. 4b minus 6b is minus 2b. And then plus 2 is 17q minus 6b. So that is, if you write this, I agree with you 100%. That is also correct. Then what?
I actually wrote it in the same question. So
how did you write
plus
it?
4a minus 6b minus 3.
4a. No. So here, from here, you mean?
Yeah.
So not from here to here, from here to here. No, okay, I understand you. Yes. So you say that now I subtract this from here. Yes. So you are telling me that I subtract minus 6b, sorry.
Yeah.
And then you get 7a. 4b minus 6b is minus 2a. And then plus 2. Yes. And then on the right hand side I have 17q plus 4a. And now minus 6b. Yes? And then?
Minus 2b.
Oh, minus 2b, thank you. And then, probably you want to work here now, yes? I don't know, but you see that I have a minus 1 here, but I have a positive 2 there. I want to make it minus 1, so what I do, I subtract minus 3, yes? So I would write minus 3, then it becomes 7a minus 2b minus 1. On the right hand side, I will have 17q plus 4a minus 6b and then minus 3. Everyone agrees with that? Yes?
And then I couldn't get it.
Okay, just let me just wait a little bit. So here, we got this one. This is a very nice strategy, even if it doesn't work, yes? Because at least we were able to make this right. So we had a strategy in mind and we followed that, we got this one. Now either you can save your argument, or if it is not possible to save it, we'll unfortunately have to cross it over and do it again. And that's the meaning of mathematics, yes? But that was a very good attempt. I don't know, can you save it or not?
I don't think so.
Yeah, why do you think the problem is? I don't know, might be you can save it. I haven't thought in your way. At least the main problem here, can you detect the main problem here? Why this doesn't go very smoothly? Because I need to have this 17 as a factor on the right hand side, yes? I have 17 here, can I naively factor 17 out? Let me ask you this question. I hope that you don't disappoint me. So if I factor this one, yes, and then I can call this one Q, and then I say that 17 times Q is that one, so 17 divides that one. Do you buy this argument? Why is that? Because there is no guarantee this becomes an integer. You can always name it whatever you want to, but the point is that this should be an integer. Okay, so this at least naive method will not work. We understand that. So this means that we want to do something better. And I don't know right now, I'm not saying this is not correct, yes, but you need to motivate me why this one is also a multiple of 17. Because if I can show that this is a multiple of 17, this is already a multiple of 17, then I can factor 17 out, and then what is left would be a factor of 17, then I am done. But at least I don't think proving this is a multiple of 17 is easier than the original problem that much. Is that understandable? Because of course the numbers are a little bit different, but I don't think it is that easy to show that 4a minus 6b minus 3 is a multiple of 17. Is that understandable? So what I'm saying is that it was a very nice strategy, but I think we couldn't save it, or immediately we cannot save it at least. Yes? Is that understandable? Yes. Any questions? Okay, let us try to change our strategy. What can you think more about it? So this was a very nice way, very natural way. By the way, you have to know these natural ways very good. And if they fail, then you have to start thinking otherwise. Yes? You should usually start thinking otherwise from the beginning. No, you should see that the natural strategy fails, then I need to look for another way to do it. Okay, so let us clean that, okay? Let us let it go. Even though it was nice, but let us erase it, yes? Any other thing to do? Okay, so let us stick to this one. Let me ask your opinion about this 7a. So Ruben actually chose the most natural way, which is completely reasonable for the first attempt. But how can I reach to 7a in a really indirect way? If you haven't had experience with that, you might be... so let me tell you, multiply both sides by something. Yes, Dimitri? No. Be careful. So let us multiply. If you multiply everything by 7 over 3, this becomes what? 7. That is for sure.
Yes.
This becomes 7a.
Yes.
Good. But then you will destroy everything from now on.
Yes.
Yes, because what happens, it becomes 28 over 3,
Yeah.
b and whatever. That's the hard part in number theory. We have to work with integers.
Then you will get.
Yes, I'm not saying that this equality is wrong. This equality remains valid, of course. But that equality remains valid doesn't give rise to any kind of these things. Yes? Okay, so now, again, 7 over 3 was the most natural thing your brain has used to it. Yes? But now, forget about this. This doesn't work. But still, I insist you can do this something by multiplication. If you want to make 3 to 7. It's indirect way. Don't think there is no other way, because the number Dimitri mentioned is the only number that directly gives you 7. This doesn't work, so forget about it. There is no direct way of making 3a to 7a. But let me offer you something. Multiply it by 8. It will work. Why?
By 8.
Yes. So let me multiply it by 8.
I don't know.
So this becomes 24, of course. And then this becomes 32. And then this becomes what? 16. 8 times 17. Let us keep it for the time being. I multiplied everything by 8. So what I am supposed to do with 24 now? No, be careful. You don't need to have numbers beautiful here. I always care about beauty, but not this time, yes? So, you don't care about having the most beautiful quotient. You want to have just a quotient. And that is the idea. I'm telling you that later in modular arithmetic, we'll learn that 24 is 7. Yes, this becomes a little bit strange, but not inequality in modular arithmetic. Forget about those things now, but instead of 24, I can write 7a plus 17a. Yes? And 17a, I can move it to the right and factor 17 out, because I need a factor. Is that understandable?
Yes, that is.
Yes?
I did this in another way.
Yes, I will ask your opinion about that. But let me finish this one. So what we want to do now, what I do here, what I write, what do I need? I need 7a, but I have 24a. So what can I write? I can write my 7a that I need, but of course I have to add 17 to it so that it becomes 24. But do I need 32? No. What I need minus 2b, but I cannot write 32 as minus unless
Plus 34.
b. And the good point is that is also multiple of 17.
Yes.
Yes? And then instead of 16, I want what? Minus 1, but I have to compensate for that by
17.
adding 17. And that was the responsibility of the designer of the question, who have fine-tuned them in a way that all of them are a factor of 17. Then it becomes 8 times 17 q, and then I move the other parts to the right hand side. So 7a minus 2b minus 1 is equal to 8 times 17 times q. 17a, I move it to the right, minus this one I move it to the right, and this one I move it to the right, yes? And now what happens? Between this one, this one, this one, and that one, I can factor a 17 out. What is left from here is 8q. What is left from here is minus a, minus 2b, and minus 1. But is this guaranteed to be in z? Yes. So this is a multiple of 17 and I am done. Yes? So this means that 17 divides 7a minus 2b minus 1. The reason that I could detect this number 8 is because I know about modular arithmetic. Of course, I could also solve it if I didn't know about this, but I have some experience, yes? Now I want to listen your method.
Okay, can you not just divide it by minus 2 first?
No? That I want you to understand. Division is only allowed on...
There.
No, if I divide by minus 2, then I will have this
the
one,
other side
okay,
as well.
this one becomes a fraction.
Yes, like do it and you'll see.
Okay, that's good, that's good. Yeah, that is something I want to follow, because now you have a strategy, you are saying.
Yes.
Okay, good. No problems, because no one can say that this is wrong. So you write 3 over
Minus 2.
a,
You
and
get
then
minus 2b,
minus 2b
minus 1.
minus 1 equals to what?
17, and then I did...
No, 17 over minus 2 again.
No, I didn't do that. I did q divided by minus 2 instead.
Okay.
Okay. And then from here I saw what I need, so minus 3 divided by 2 is 1.5, minus 1.
May you close the door? Thank you. Yes?
Yes, and then I just added 8.5a.
May I hurry?
Okay, so I add 8.5
A. Yes.
You mean decimal points, yes?
Yes.
Okay, and then this becomes exactly 7a
And then minus 2b.
minus 2b
Minus 1.
minus 1, very
and
good.
Then, and then 17 divided by... I wrote minus 0.5 cubed because it's easier.
Yes, yes.
No. Oh yeah. No, I didn't do that.
Yes? Is that what you mean?
Yeah, no, I didn't mean that. I wrote 17
Yeah.
times minus 0.5 cubed. I just wrote it in decimal.
Okay, so tell me what should I write?
Okay, 7.
I am adding 17.8 to both sides.
Yes.
Then definitely this becomes 7a
Yes.
minus 2b minus 1. Okay, whatever you say, I will write it.
Okay, 17 times minus 0.5 cubed. I just like decimal forms.
Is this one?
Yes.
Am I, so,
And then plus 8.5.
8.
It's 8. And now 8.5 is 0.5, or it's half of 17. So
Yes.
you can factor it.
Factor what out?
So that would be 17 minus 0.5 cubed, and then plus 0.58.
Yes, I agree.
And then
It's not finished yet.
isn't that an integer?
No. Is it guaranteed that this is an integer? No, because I can convince you there is no guarantee unless you tell me why. If you can say why, then perfect. Yes, that's also something I'm really happy what you did. There is one flaw in it, because what Ruben mentioned was completely right, but he has to defend the last part to be a multiple of 17. Your task is to tell me why this is an integer. Might be you can. Let us think. If it works, that would be also a success. Yes, you see that you can, if you are creative, you can find. Let me first of all convince you it is not trivial. Yes, because you are playing with decimal points, but there is nothing. Decimal point is 1/2. Do you agree? So this is a over 2 minus q over 2. So in principle, that number is a minus q over 2. Yes? Do you agree? But is there any guarantee right now
No.
that this is an integer? No. Unless you can show the numerator is even. Yes? This method up to here, from algebra point of view, it's completely correct. Exactly like Ruben's was correct. But now, if you can convince me a minus q divided by 2 is an integer, in other words, if you can convince me a minus q is even, then this solution is 100% correct. But I just want you to know there is a very small flaw right now. Yes? Okay, but let us think, by the way, might be we can save your solution because it was nice, yes? Is there any way that we can convince ourselves, unfortunately I erased a lot of things, a minus q is even. So where was the starting point? Yes, the starting point was this one, yes? Okay. And then we had this. Yes, I am convinced now. Your solution is correct, but you have to finish it. Why a minus q is even? Yes?
I have a question.
Yes?
If you, in the step before, if you multiply 17 inside,
Yes?
you won't have what you had before. Because you multiply 17 by 0.5 cube. And you had 0.5 cube before you factored 17 out.
No, that's correct. If you multiply 17 here, you will get this one.
Oh, yeah.
And if you multiply 17 here, you get 8.5. No, algebraically it is intact. Yes? Unless you want to say no. Agree, everyone? Okay, so let us not distract each other, okay? So now I am convinced this solution is 100% correct. If you can defend yourself that a minus q divided by 2, yes, is an integer, you have to convince me that A minus Q, this is, if you write it in the exam and leave it, then it is not 100% correct, yes? And I would say it's more or less 100% wrong, because it means that you don't understand what is the meaning of divisibility. But now, can you defend why A minus Q should be even? Look here. It's a little bit indirect. You need to expand your point of view. This is actually telling you A minus Q is even.
A minus Q.
I want to lubricate your brain cells a little bit in number theory, yes? This will work. This is just, by the way, it's very natural, because this is the first time that you are in camp. So let me tell you something. Can I move A to the other side? Yes or no? I can write 2A plus 4B plus 2 is equal to 17Q minus A. Agree?
Yes.
That is completely clear. But I am claiming this number is even. Why? Yes, it is multiple of 2. I can factor a 2 out, any number multiplied by 2. So if I factor a 2 out, it becomes something, who cares? 2 something integer is this number. This one is an even number, definitely. So the right hand side should be even. Yes? Okay, so the right hand side is even. But this is 17Q minus A. How can I say that A minus Q is even? No? I can write it as 16Q plus Q minus A. Yes? Let us put it this. Do you agree that this number is this number? Okay, 16Q is already even.
Yes.
Yes? The whole expression is also even. So this part should be even. Is that understandable? So the arguments are so simple. Yes? So what I'm saying is that by moving A to the other side, I was able to show that this expression is even. This expression can be written in this form. So this means this expression is even. 16Q is definitely even. So this cannot be odd, because even plus odd becomes odd, but we know that this is even. So Q minus A has to be even. And if Q minus A is even, A minus Q is also even, and then we are even. Yes? But that was a very nice thing, so let us just, yeah. Good. Yeah, no, but now at least you motivated me to tell you something else. So that was good. Is that understandable? So this method was not probably, the reason that I probably could get this one, I don't remember how I could do it when I was at your age, but my brain has used to modular arithmetic so much so that I can probably find those numbers not that hard. And that would be the next part of the lesson. I'm trying to train your brains for that one. But that's also a very nice way to do it. Yes? So be careful. So what Dimitri said might be I said no immediately. It was not a good idea. Because here still we are working with decimal points. So we went to the realm of decimal points, but we were able to survive back to the realm of integers, yes? Yeah, that's the way that I was thinking, yes? We were close to be going under the water, but we saved ourselves, yes?
I have a question.
Yes?
Instead of going from 3A plus 4B plus 2 to 7A minus 2, can you go like the other way around? Bring 7A minus 2B minus 1 to be 3A?
No, I wouldn't say. So you know that if you, this problem is a particular case of proving that this implication is true. If P, then Q is an implication. I told you that if this is true, then show that one is true. So if you want to prove this, this is your hypothesis or premise, it's guaranteed, you should be able to show this. If you want to do it the other way around, we will study a little bit about these kinds of proofs. That is called proof by contradiction. So I want to show that if this happens, this also happens. One equivalent way to show this is not going from Q to P. Because if P, so the truth of P then Q and Q then P are not related at all. Sometimes this is true, this is not true. And sometimes this is not true, this is true. Sometimes both are true, sometimes both are wrong. But what you can write, you can say that this is negation of Q implies negation of P. Yes, if you can show this, then you are done. So I want to show that if P is true, then Q is true. One way to show this is to assume that Q is not true and show that P is also not true. But you cannot say that if I show Q, then P, I succeeded to show P, then Q. Let me give you a simple example. If I give you x equals to 2, it is guaranteed that x2 is 4. This is true. But if I interchange them and I write x squared is equal to 4, guarantees that x is equal to 2, this statement is false. Yes? So this, be careful. But if you interchange and simultaneously negate them, this is the negation symbol, then yes, you are right. But that is not helpful here, because you need to assume that if this is not true, then I show that that one is not true. Working not true is harder here in this case. Yes, is that understandable? Any questions here? So I think you learn a lot of things. That this is the reason that I want to talk about these things. Solving that problem, that's the solution. That's not helpful. Okay, first of all, don't freak out. This will not be in the exam. Okay, so yes, but this I just want to tell you, I will go back to the level of the book as usual. But I want you to learn these things. Okay, if you don't learn these things, then we will have a little bit of trouble later. Yes, now everything is okay. So I was talking about Dimitri's method. It's still Dimitri. If you can defend yourself after dividing by fractions, that's okay. Okay. Yeah. Yes. So this one was working here. So that's also another method. By the way, I didn't know about this method before the lesson. You just told me something, then I tried to follow to make it complete. Yes. So that's why I'm saying that you can be always creative. Yes. Anyway. Okay. After all these talks, now can you solve this one for me, please? Yes. Yeah. This second one. The second one, I don't know. I should probably interchange these two. This one is probably harder. Yes, I will pause the recording a little bit so that give you time. Okay. Yes. Yes, of course. So I don't know. You start from here. What you know is that x squared minus y squared is x times q, yes? So if I want to be sure that I have to write there exists a q in z such that this happens. Yes? Oh, sorry. So the other way around.
Yes. Oh my God, you confirmed.
So let me write. So x squared minus y squared divides x. So this implies that there exists a q in z such that the right hand side is the left hand side multiplied by that q. Yes, that's correct. Okay, we need to have a close look on the on what we want to gain. We want to have x plus y involved, and then we want to have y on the right hand side. Okay, so what is your suggestion? We factorize. Yes. This is a conjugate pattern. It should be very familiar to your eyes, and this is relevant. Because at least you see x plus y appears somewhere,
Yes.
so that is good. Even myself cannot see everything until the end of the problem. I see that x plus y is involved, so let us just do that. So then this means that x is equal to x minus y times x plus y times q. Then this is what we get.
Yes. Vad gör man nu?
So let me see exactly. If I add y to both sides, the intention is clear because I want to make x plus y on the left hand side. So let us just do it, okay? So this becomes x plus y equals to x minus y, x plus y times q plus y. Okay. And then what?
You can like x minus y plus x plus y q. You can repeat that to the other side.
Should I move it to the other side?
Yeah.
Yes. So x plus y, I move this term to the left. What was the motivation? Because my motivation is to have a factor of x plus y. X plus y appears there and here. So you see, it was not hard at all. Yes? So I'm just thinking logically. So x minus, actually Dimitri, x plus y times q is equal to y. There are two motivations behind this movement. Yes? The reason is that, first of all, I want to have y alone. And then I want to have a factor of x plus y somehow appearing. And this gives me both of them, yes? So what happens, we don't need this line, let me clean this. Now you see immediately that x plus y can be factored out. And then what is left from this one is simply 1 minus, I pull this one out. So here I don't emphasize on that algebra, because algebras are actually very elementary in the number theory. This becomes y. The only thing that I have to convince myself is that, is this an integer? And I think everyone agrees that this is an integer. Why? Because x and y are integers, given in the problem. Q is also an integer, so hopefully you agree that this is an integer. Yes? Even though if I have a negative sign. So this belongs to z, and I am done. So this means that x plus y multiplied by an integer is equal to y. So this means that x plus y actually divides y. Yes? Is that clear? Yes, thank you. This works. Okay, this is a little bit of more challenge. Okay, so let us just again wait for you to see that if you can solve this problem. Because now this is the first time this number is also changed. So 7, yes? Let me just give you a little bit more time. Okay, any progress?
Wait, this is it.
Yes.
Yes? You got the answer? Okay, so can you just, you can tell me what to do. Or if you want, you can come and solve it here.
She got the answer. We had
So you solve together, that's the teamwork, yes? Yes. No problems, you can, either you can come here and solve it, or you can tell me how to solve it. Because I don't know. Do you want to come here? No? Okay. So tell me at least where should I start from? You start from here? Yes? So we say that 7 divides a minus 3b. So might be you want to write there exists a q in z such that a minus 3b is equal to 7q. Okay, what would be the next step you are suggesting?
square, do everything to the power of 2.
Yes. What is the motivation behind that?
To get 49.
To get 49. Yes. So that might be that's a good idea. We don't know yet, but let us check the idea. So please listen, this is important. Okay, so this becomes this.
Yes.
The motivation is at least this is a good idea to make 49 appears. Of course, I could multiply by 7 to make 49. Why? Can you explain why did you choose this one instead of multiplying by 7? What was your instinct behind that? Yes. Yes, that I understand in Swedish. Yes. So yes, that is actually the reason that we have also power of 2 here. Yes. So might be that's also a good idea to multiply by 7. I will get 49, but I will not get quadratic terms here. So this is why I myself also prefer at least the first thing I want to do is this one. Yes. Might be this doesn't work, then I have to go and fix it again. So then I hope that you want to raise it to power 2. Yes. The first one to power 2, 2 times the first one times the second one, and the second one to power 2 is equal to 49q squared. So far so good. So then what?
Multiply each side by 2.
By 2. The motivation is this
To
2.
get 2a.
Yes? So you see, multiply by 2. I multiply by 2, it becomes 2a squared minus 12ab plus 18b squared. And then, if you want, I can multiply it by 2 or just leave it. Yes? Let us leave it. Yes? That's good.
And then
Yes?
you're supposed to get 37ab and 31b to the power 2. So you have to see, okay, what should I add and what should I subtract to get that?
So you just learned this in the first problem.
Yes.
That's the only point that I'm telling. If you want to be a good problem solver, you have to get experience. You have to learn from your experiences, especially from your bad experiences that you couldn't solve the problem. Yes, and now it's finished. Thank you. Thank you very much. So, so what we are saying is that I told you this was. You see, that was not exactly this problem, but the same idea again works for this problem. So what we are saying is that I need 37ab. Unfortunately, I have minus 12ab. So what can I do? I write 37ab. Who cares? Yes? Because I need it. But unfortunately, because this is mathematics, I have to respect the rules. I have to go back to minus 12ab. How can I do that? By subtracting minus 49ab.
Yes.
And when I see this 49, I become very happy. Because I know what I'm doing. This 49 should be moved there and I will have my factor. And the same story here. I have 18b squared, but I need minus 31, but I would write minus 31b squared. I need to compensate, go back to this one. How? By adding this beautiful 49 again. So, did you believe that you would like 49 that much? Yes? Yeah, but in mathematics happens, suddenly you start loving a number because you need it. Yes? And it appears. So this becomes 2a squared plus 37ab minus 31b squared. And then I move whatever 49 is to the right hand side. And let me do the algebra simple. I factor 49 out. What is left from here is 2q squared. And when I move it to the right, it becomes positive. 49 is out, so it becomes positive ab. And then it becomes negative b squared. Yes?
Yes.
But I told you that this is the first time we don't care about beauty because we just care about being an integer. And is this an integer? Q is an integer, A and B are integers, so this combination is definitely an integer, and then I am done. Yes, thank you very much. Yeah, that was a very good class. So you see, this was a very good experience because you saw that the same idea that I used for the first problem was also very helpful in this problem. Yes? You shouldn't expect in mathematics to get the same problem. Of course, I will respect to in the exam or something, but in principle you should be able to solve problems that you haven't seen before. What is the point of just, I don't know, having one Sudoku table copied 365 times and then in the morning wake up and solve the same one? I don't know, might be you enjoy, but I will not enjoy and solving the same problem over and over. But I just want you to see, it doesn't matter, by the way, if you are working number theory, if you are working geometry or algebra, the same way of thinking you need to learn. If you start learning that, then it will be very helpful for even physics and chemistry, or I don't know, any kind of studies. You need to see this logic. Okay, now you had some experience before here. Now you are happy. Suddenly I changed the problem. Yes. Then you have to redo it. You need to organize your thoughts again. So I don't know. I can give you a little bit of time, even though 5 minutes is left. But I will give you this 5 minutes. And then I will solve this one, that one, and this one. I want to put them as an exercise for you. If you cannot solve it today, you can think a little bit about this. The best time is the weekend, yes? Just have a cup of coffee and then start solving the problem. Believe me, that's the best experience. You feel it, especially if it's raining, yes? Or there's a snow outside. You enjoy more, yes?
How many points?
Okay, so I recommend you to think about these 3 problems at home. I don't think you will have any problems with these 2 because more or less they are of the same spirit. But this is a little bit different. So try to think that if you can solve these problems. Next time I will start with these problems and then immediately I go to the next topic, which is called the division algorithm. And after division algorithm we go to the modular arithmetic, which is the most fun part of number theory. Yes? Okay, thank you very much.